Welcome to my discussion of solving exponential equation. At the end of my discussion, you are expected to possess these knowledge and skills such as apply the steps in solving exponential equations and solve exponential equations. Before we proceed with the new lesson, let us have first short recall regarding rules of exponent. Let us have product of powers rule. It says that when x raised to m multiplied by x raised to n, it is equivalent to x raised to m plus n. Example, 3 raised to 2 multiplied by 3 raised to 1, it is equivalent to 3 raised to 2 plus 1. And 3 raised to 2 plus 1 is 3 raised to 3. In here, you add powers together when multiplying like bases. Next, quotient of powers rule. It says that when we divide x raised to m by x raised to n, it is equivalent to x raised to m minus n. First case, m is greater than n, and x should not be equivalent to 0. Example, 3 raised to 2 over 3 raised to 1 equals 3 raised to 2 minus 1, and that is 3 raised to 1. We subtract powers when dividing like bases. Another case is when m is less than n. Example, 3 raised to 1 over 3 raised to 2, it is equivalent to 3 raised to 1 minus 2. We use the same procedure. We subtract powers when we divide like bases. It is equivalent to 3 raised to 1 minus 2 is 3 raised to negative 1. And 3 raised to negative 1 is equivalent to 1 over 3. So later, we will have a deeper discussion regarding negative exponents. Let us have power of a power rule. It says that when x raised to m raised to n, it is equivalent to x raised to m multiplied by n. Here, multiply powers together when raising a power by another exponent. Example, 3 raised to 2 raised to 2. It is equivalent to 3 raised to 2 multiplied by 2, and that is 3 raised to 4. Next, power of a product rule. Power of a product rule. It says that when x multiplied by y raised to n, it is equivalent to x raised to n multiplied by y raised to n. Here, distribute powers to each base when raising several variables by a power. Example, 3 multiplied by 2 raised to 2, and that is 3 raised to 2 multiplied by 2 raised to 2, and that is 3 raised to 2 is 9 multiplied by 2 raised to 2 is 4. So 9 times 4 is 36. Simply, 3 times 2 is 6 raised to 2, which yields also to number 36. Next is a power of a quotient rule. It says that when x divided by y raised to n, it is equivalent to x raised to n over y raised to n, provided that y should not be equivalent to 0. Example, 2 over 3 raised to 2, and that is 2 raised to 2 over 3 raised to 2. Here, we distribute power to all values in a quotient. Let us have negative exponent. When x is raised by negative n, it is equivalent to 1 over x raised to n. To change a negative exponent to a positive one, flip it into a reciprocal. Reciprocal of x raised to n is equivalent to 1 over x raised to n. Example, 3 raised to negative 2 equals 1 over 3 raised to 2. So, possibly 3 raised to negative 2 came from 3 raised to 2 over 3 raised to 4. And that is equivalent to 3 raised to 2 minus 4, and that is 3 raised to negative 2. Also, it may come from this number, but I will use it in different way. 3 raised to 2 is equivalent to 3 multiplied by 3. And 3 raised to 4, it means that you need to multiply 3 by itself 4 times. So here, you canceled out 3, and remain, it is 1 over 3 raised to 2. As you can see, 3 raised to negative 2 is equivalent to 1 over 3 raised to 2 by transitive property of equality, since 3 raised to 2 over 3 raised to 4 is equivalent to 3 raised to negative 2, and 3 raised to 2 is 3 raised to 2 over 3 raised to 4 is also equivalent to 1 over 3 raised to 2. Therefore, these two numbers are equal. Next, let us have zero exponent. When x is raised by a 0, it is equivalent to 1. Example, 3 raised to 0 equals 1. Possibly, 3 raised to 0 came from this 3 raised to 2 over 3 raised to 2, which is equivalent to 9 over 9, and that is equivalent to 1. Or, in different manner, 3 raised to 2 over 3 raised to 2 is equivalent to 3 raised to 2 minus 2, and that is 3 raised to 0, and that is equivalent to 1. Therefore, 3 raised to 0 is equivalent to 1. Or, any base raised to the power of 0 becomes 1, where x does not equivalent to 0. Next, fractional exponents. So, when x is raised by a fractional exponent, x raised to m over n, it is equivalent to nth root of x raised to m, or you can write this as nth root of x raised to m. Example, 2 raised to 3 over 2 equivalent to square root of 2 raised to 3. And normally, 2 as index is not written as index. So, it is read as square root of 8 or square root of 2 raised to 3. To summarize, laws of exponent, also called rules of exponents, come from these three ideas. First, the exponent says how many times to use a number in a multiplication. But if your exponent is a negative exponent, it means division, because the opposite of multiplying is dividing. A fractional exponent like 1 over n means to take the nth root. So, x raised to 1 over n equals the nth root of x. And please, don't forget this concept that 3x equals 9 is not equivalent to 3 raised to x equals 9 because in this portion, the value of x is 3. Having a replacement value of 3, we have 3 multiplied by 3 equals 9. And in this portion, the value of x is equals 2. So replacing x by 2, 3 squared equals 9. Now let us proceed with the lesson proper by discussing first what is exponential expression. It is an expression of the form a times b raised to x minus c plus d, where base should be greater than 0 and be equivalent to 1. Why? Since actually many expressions with negative bases do make no algebraic sense, or they do not define any real number, and since base of 0 leads to just a constant function, so we usually add the following restriction to exponential expression, that base of an exponential expression must be positive. Example of exponential expressions are 3 times 4 raised to 3x plus 2, 4 raised to 3x plus 2 plus 3, or simply 4 raised to 3x plus 2. Here you have a multiplier of 3, and here you have a constant number which is positive 3. Now, we will discuss what is an exponential equation. It is an equation involving exponential expression. Example, 4 raised to 3x plus 2 equals 7, and 5 raised to 3x equals 25 raised to 2. Actually, you need to have at least one exponential expression in every exponential equation. And in solving exponential equation, you may apply the laws of exponent, and your goal in solving exponential equation is to find value or values of the unknown variable of the equation. Also, we will apply property of equality for exponential equations when we are solving exponential equation. So this property is useful to solve an exponential equation with the same basis. It says when the bases on both sides of an exponential equation are equal, then the exponent must also be equal. Example, b raised to n equals b raised to m. If b raised to n equals b raised to m, then n equals m. Basically, this states that if the bases are the same, then we can simply set the exponents equal. Here are the steps in solving exponential equation. First, express both sides of the equation in terms of the same base. Second, equate the exponents. Third, solve the resulting equation. And then fourth, check the solution. So you will have better understanding of these steps when we apply this in the following exponential equation. So let us get started. Let us have the first example. 5 raised to 3x equals 25 raised to 2. First step, express both sides in terms of the same base. Your goal here is to make both sides of the equation having same bases, so think of a possible number that will give you equal bases for this equation. In this case, we have base of 5 because 25 can be expressed in 5 squared. Since you have same bases, proceed with step 2, equate the exponents. So simply set the exponents equal. 3x equals 4. Using power of a power rule, to multiply by 2 is 4. And solve the resulting equation. Here, you will divide both sides of the equation by 3 to solve for x. So Here, 3 divided by 3 is x, and then x equals 4 over 3. To check, use the original exponential equation and replace x by replacement value 4 over 3. So 5 raised to 3 multiplied by 4 over 3 equals 25 raised to 2. So 3 multiplied by 4 over 3 is 4 because 3 divided by 3 is 1 and 1 multiplied by 4 is 4. And 5 raised to 4 equals 25 raised to 2. To simplify, 5 raised to 4 is equivalent to 625 and 25 raised to 2 is equivalent to 625. Therefore, x equals 4 over 3 is a solution for this given exponential equation. Let us have example number 2. M raised to 3x multiplied by m raised to negative 2 equals m raised to x multiplied by m raised to 8. As you can see, we have same bases already, so we will now skip step 1 and proceed with the second step, which is to equate the exponents. To equate the exponents, we will apply rules of exponents over multiplication. So we just add the exponents of the same base. So we have 3x minus 2 equals x plus 8. And to solve for x, we use addition property of equality, wherein we add positive 2 in both sides of the equation as well as negative x in both sides of the equation. So we have to cancel out negative 2 and positive 2, positive x and negative x. So we have 2x equals positive 10. And divide both sides by 2. 2x divided by 2 is x, and 10 divided by 2 is 5. Therefore, x equals 5. To check, we will use this original equation and we will use this as our replacement value. So, from this, we have m raised to 3 times 5 times m raised to negative 2 equals m raised to 5 times m raised to 8. And 3 times 5 is 15. So, m raised to 15 times m raised to negative 2, it is m raised to 13. Simply add negative 2 to positive 15. So it is m raised to 13 equals m raised to 5 multiplied by m raised to 8. It is m raised to 13. Therefore, the value of x will make exponential equation equal. Let us have example number 3. 3 raised to x plus 1 minus 3 squared equals 18. First step is to express both sides in terms of the same base. In this case, you can actually manipulate terms in any side of the equation. So since 3 squared is equivalent to 9, so you have 3 raised to x plus 1 minus 9 equals 18. So by addition property of equality, you have to add positive 9 in both sides of the equation. So you canceled out negative 9 and positive 9, and then you add 18 and 9. So remain, we have 3 raised to x plus 1 equals 27. From this, we can express both sides in terms of the same base. And that number on that base will be base of 3. So after that, we will proceed with the second step, which is to equate the exponents. Since you have same bases na, you can simply set the exponent equal. So we have x plus 1 equals 3. Then using addition property of equality, adding -1 in both sides of the equation, you have x equals 2. Okay, to check, we will use this original equation and having this replacement value of positive 2. So, replace x by positive 2. We have 3 raised to 2 plus 1 minus 3 squared equals 18. And 2 plus 1 is 3, so we have 3 cubes minus 3 squared equals 18. And 3 cubed is 27. 3 squared is 9 equals 18. 27 minus 9 is 18, and 18 equals 18. Therefore, a solution of positive 2 satisfies the exponential equation. Let us have the last example. 9 raised to x equals 1/3 raised to 1 minus x. First, we need to express both sides in terms of the same base. Here, you can express 9 as 3 raised to 2 and 1/3 as 3 raised to -1. So here, you have same base of 3. So you can now equate the exponents using power of a power rule. So you have to multiply 2 by x and -1 by 1 minus x. So you have 2x equals -1 times 1 minus x. And 2x equals -1 multiplied by 1 is -1, and -1 multiplied by -x is positive x. So solve the resulting equation using addition property of equality, adding -x in both sides of the equation. You will get x equals -1. To check, we will use this replacement value, which is -1, in replacing x variable. So it will become 9 raised to -1 equals 1/3 raised to 1 minus -1. So 9 raised to -1 is 1/9 equals 1/3 raised to 1 minus -1 is actually positive 2. So 1/3 raised to 2 is 1/9. So 1/9 equals 1/9. Therefore, a solution of -1 satisfies the given exponential equation. To sum up, these are the steps in solving exponential equation. And here are my references in creating this material. Again, thank you for watching and listening. God bless and keep safe.